In this recording, we're going to review some of the factoring techniques for polynomials, specifically quadratics, that you may have learned in algebra, you may have forgotten. It's cool if you forgot, but we're going to review them here. So the first thing I'll always want you to look for is there a greatest common factor in these terms? So I'm looking at each one of these terms to determine, is there a GCF here? And there is. There's a number that goes into all of them. I also should be looking for variables. Is there an amount of each variable? Is there an amount of x's in this case that goes into each term? There is not. So given that 3 is the GCF, I'm going to put that out in front. Okay, so I'm always looking for the GCF first. Let's make that note. Always look for this first one, right? GCF. Always look for that first. Number 1. So I'm going to divide each of these terms by that GCF, by that 3, right? And inside the parentheses, I'm going to write down what's left. So 3 divides, so I've got an x squared minus 2x plus 3. And I can double check that that worked. You can always check factoring by multiplying, by distributing. So you can distribute the 3, you can distribute the 3, you can distribute the 3, and it seems like it is going to be equivalent to our original expression. I should be also looking on the inside to see if there's any way to factor this further. I can't think of any way to multiply to be 2 numbers and have them add up to -2. So I'm going to assume that's factored completely. Next example. Do you remember what we're going to look for? Always, right? GCF, always. In this case, there's no number that's a GCF. Believe it or not, this is one of the hardest ones that I've noticed that students have a heck of a hard time trying to factor. So let's look for a variable that's in common. Of course, x, right? So we're just going to do it the same way. We're going to write x out in front. We factored it out. And essentially, you can do this part in your head, or you can write it. At first, it might be helpful to write it. The x squared and the x divide out to just give an x. The x divides out to just give a 5. All right? Then so mentally distribute it back. Yeah, x squared plus 5x, it looks all good. All right? The next kind we want to consider is this a difference of 2 squares? Do I have a square? Well, first of all, is there a GCF? You should be looking for that. We said we'd always look for that first. And once I've established there's not a GCF, is there a squared term minus another squared term? In other words, there's only 2 squares. A difference means an answer to a subtraction question. So if it is, well then I can write it as a particular pattern of factoring. Okay, I take x squared, I take its square root. I'm going through this kind of fast because this isn't the first time you've seen such a thing, right? You've done this for since algebra at least. And then because this is a perfect square of 8, and of course we have a positive and a negative 8 inside. If you were to distribute these out, you get x squared, you get negative 8x, positive 8x. Those add to 0, okay? And negative 8 times positive 8, sure, that's going to be a negative 64. So once you understand this pattern, those become pretty straightforward. Okay, this one I call a quadratic trinomial. Tri meaning 3, like a tricycle, right? It's got 3 terms. Doesn't have a GCF, although we should think about that. Let's go ahead and put a 1 in here as the coefficient. Okay, this particular quadratic is not a difference of 2 squares. There's not just 2 terms, even though there's a square. 9 is a square, but there's not just 2 terms with a perfect square. So let's try a different technique. Okay, we're going to multiply 1 times 20, and over here we're going to think about, okay, 20, and I need 2 numbers that multiply to be positive 20 and add to negative 9. So jot those down when you have them. Okay, so hopefully you jotted down negative 5 and a negative 4. Hopefully this is a piece of cake for you. All right. Now some people use a little box. I'm going to show a little box over here just because it's going to lead into a technique we're going to use if this leading coefficient is not 1 and it's not obvious to you what to do. Okay. I'm basically going to split this up, and I'm split it up in my head as x squared minus 5x minus 4x plus 20. Okay, you might say, well, I can already do this in my head. I can factor these. Well, that's cool. That served you well that you remembered that, but let's see if we can appreciate this method. You can see how this is really the same, right? Negative 9x is the same as negative 4x and negative 5x. So let's put all those terms in the panes of the box. Now you might never use this technique again for this kind, but you might find this technique to be useful if you have a leading coefficient that's not 1 and you struggle. So I'm just going to show you how this works. And then it's simply take your greatest common factor. Check this out. X squared is easy, right? X times x makes x squared. Well, what times x makes negative 4x? Well, it's just negative 4. And what times x makes negative 5x? Well, it's just negative 5. And of course, negative 5 times negative 4 gives us our 20. So here are our factors right here, right? X minus 5 gets multiplied by x minus 4, and we've got our factorization. I don't even really need to show how this multiplies out, because it's right above, right? All the 4 terms. And it checks out. All right, again, what do we say the first thing we're always going to look for? Our GCF every single time. So I'm seeing a term that goes into all these, a factor of 4. All right, sometimes teachers even get the wrong terminology. So a factor of 4 goes into all of them. So let's factor that 4 out. Okay. I want you to write in parentheses what you think it is, then play the recording when you've got it. Okay, so hopefully you paused and wrote down, this is going to be an x squared, this is going to be a 5x, and this is going to be a 6. I should try to factor this further, okay? So I should be looking here to see if maybe I can factor this, and I think I can. I think with 6, I'm thinking about the factors that multiply to be 6. That would be 6 and 1, 2 and 3, and of course 2 and 3 is the pair that also adds up to 5. So that works well. So I've got the 4 still. Don't lose that 4. And then I'm just going to break down this quadratic into x plus 2 times x plus 3. That's what's called the complete factorization. I know I can't go any further because there's no way to factor x plus 2 and there's no way to factor x plus 3. Okay. Last example. Okay, we said we look for a greatest common factor first. I do see one. I see a 2 that goes into both. Okay, so let's factor out a 2. Write in parentheses what's left and then play the recording. So hopefully you wrote 4c squared minus 25d squared. And I shouldn't stop yet. I should consider, are there any techniques I can use to factor what's in parentheses here? Pause the recording, see if you can factor it. Play when you're ready. All right, so hopefully you identified, yes, there's no more greatest common factor, but it is a difference of 2 squares. 4c squared, well, I don't want to lose that 2. Let's bring that 2 down first so we don't forget it. 4c squared has a square root of 2c. 25 is a perfect square, and so is d squared. So that'll give us 5d and 5d. And of course, plus or minus, doesn't matter the order you put the plus. You can put the plus here or here, but you have to have 1 plus and 1 minus. Thanks for watching.